Hi, hello everyone. Welcome to this video again with WebGPU, but this time we're going to cover it for desktop. What does that mean? That means we're not going to run for the browser anymore. We're going to run, well, basically for a desktop mode for Linux, Windows, Mac. You could try the mobile as well. But for those who don't know what WebGPU even is, I just prepared some small presentation so that we can figure out what it is. And what WebGPU basically is, it's kind of an API that exposes that performs rendering and computation operations on the GPU. What does that mean? You have GPU, graphic processing unit. You somehow have to call it to give it tasks to do what you want to do. Usually it's just graphics, but you can use it for computation as well, machine learning, image processing, stuff like that, etc. So we do that on the web. Usually there was WebGL, which was focused just on rendering mainly. And now the new standard is actually WebGPU as well. Is it a replacement for WebGL? No, it's not. Can you use it instead of WebGL? Yes, you can. So we have WebGPU. It's very similar to modern rendering APIs, which is Vulkan, DirectX 12, or 3D 12, which is a subset of that DirectX, or Metal on macOS. So it's kind of similar to those. Why did I create this slide? WebGPU, if you don't know, it doesn't run on the graphics card directly. It's actually, it will use Vulkan, DirectX 12 or Metal. Does that mean that it's like some kind of abstraction layer that makes everything easier? No, it's actually very similar to those APIs. It's even a bit harder than Metal, probably easier than Vulkan, which has a lot of micromanagement. It's not that important. What's important is it's similar to those, and in the way that you're going to use it is similar. If you don't know them, don't worry, WebGPU is API for itself. If you know WebGPU, you can. It's just that it's going to be easier if you know any of those. If not, then if you learn WebGPU, one of those is going to be easier to learn next, and etc. But here it's also important that it runs either on Vulkan, DirectX 12 on Windows, or on Metal it might, or sorry, on macOS it will be Metal. Okay, it's very similar to those. It's subset of those. What does that mean? So we're going to cover this a bit later. This vertex fragment and compute shaders. If you don't know what that is, you can probably sleep on this part a bit. But for those who do know, basically with WebGPU you can either do vertex shaders, fragment shader, very common. What's new is it has compute shaders. So in WebGL you didn't have compute shaders, now you do. But what's also important for those who are working with DirectX 12, Metal, Vulkan, it doesn't have any other shaders. It's subset of those, so you cannot expect ray tracing anytime soon. Maybe something like that, maybe some other shaders, I don't know, maybe geometry shaders, stuff like that. But for now, we just have vertex, fragment, and compute shaders. There are two implementations of WebGPU. So what does that mean? So someone had to actually write WebGPU and to actually use Vulkan, Metal, DirectX 12, right? Someone had to write WebGPU, and basically they had to wrap it around those. So we have two main implementations, maybe some other. One is Dawn. It's used for Chromium-based browsers, means Edge. It means Chrome, obviously. It's written in C++. The other one is WebGPU native. That's done by Firefox team, and it's written in Rust. But for this, we're going to use actually C#. I skipped slide on purpose, but we're going to use C# and Silk.net. Silk.net is just a NuGet package for C#. It provides low-level bindings for all kind of APIs, among them WebGPU native, and we're going to use WebGPU native, which is implementation by Firefox. Why? I don't know. I just had my project, I was using it, I was happy with it, so I'm just going to use it. What did I also want to mention? despite the name, it's not only for web, which we already determined, can be run on various devices, Windows, Linux, macOS. I have game running on all three, browsers via WebAssembly or natively via JavaScript API, and mobile as well probably. And the tools that we're going to use for this series, I'm going to use Visual Studio, and then every second video I'm going to do it on Linux with Rida. I'm not going to do it on macOS because it's just easier for me, because I would have to change capture card and setup. So, but I do expect it to run on macOS. If you run into any issues during these videos on macOS, please do let me know. And then for the tools as well, you can use Visual Studio Code as well. I'm going to do it with Visual Studio and Rida. So those are the tools. So regarding tools, Visual Studio, you can find it online. It's very popular when it comes to C#, especially, I mean on Windows, right? It's for Windows only. But if you're on Windows, it's free option. You can download the community version. You're probably going to be happy with it. It has everything. And on Windows, I'm going to use it. But when I do Linux-based videos, I'm going to use Rida. So it's paid software. For the free software, you can use Visual Studio Code if you wanna. I just haven't used it that much and don't have too much of experience with C# and Visual Studio Code, so I just went with Rida, and I'll be using that every second video when I'm on Linux machine. With that said, we can start coding, and I'm going to use Visual Studio here, and we're just going to create a very simple project, and this time we're just going to focus on window. So we're going to create a window, and next time we're going to attach WebGPU to it. So we can get started. So here I can just start Visual Studio. So if you downloaded it, you're going to see something like this. We go to create a new project. You need to find console app. Runs.NET on Windows, Linux, and macOS. That's perfect. So I'm just going to call it WebGPU FPS game. I think that's fine. For the name, it's not important. It's just that namespace is going to be by default this. You can place it wherever you want, and then I'll just create it. I'm going to use .NET 8. 6 is probably fine as well. So I'm just going with latest. If you don't want to use it, you don't have to. There is nothing forcing you. So what did I mention in one of the slides? That we need to find the bindings, right? Silk.NET bindings. So if you go just right click, and then we can find manage get packages. And so I need two packages. So one is going to be for windowing system. And I'm just going to say windowing. Hopefully it will find it. So we can find it here, silk.net.windowing. I'm going to install that. And it's going to install a bunch of other packages as well. Native GLW. Yep, that's good. So just regarding the windowing system. Basically, if you're on Windows, Linux or Mac, every one of those has a different windowing system, right? It's Cocoa on Mac, it's Windows 32 or whatever you use on Windows, and then on Linux it's either, I think it's X11 or something, I don't even know. I never tried on native Windows, but that's why we have libraries that actually are kind of like WebGPU implements Vulkan Metal and DirectX. We have also for windowing system, we have similar solutions, which just wrap Windows around so that it's easy to use. And I'm going to do that. And then I just want WebGPU, find as well, and install that. And here I'm just going to use native. You can use down. I would recommend native maybe for this video. It's going to be easier. So why native? No specific reason. I just used it on one of my projects and it was easy to set up. I mean, the down and native are very similar, like 99%. So you can go wrong with either of those. So we have that, and here I'm just going to, actually we can just go here directly. So what I want to do is just create a window, and I'm going to say window, and here you can just place using seal.net.windowing, so because we need it for window, and I'm just going to say window create, and then it takes window options. So here I can say window options, and you can just say default, that's fine. And then for Windows options, we can set size. It auto suggested already, and I'm just going to use this size. You can use whatever you prefer, and I'm going to say this, move this to usings. All right, we have window size, and then we can say title. It can just be FPS game. That's quite all right, and we can test those Windows options. And the third thing that we need to do is just say window run. And if I try to start it now, it should create a window, and it did, just on the other side. And here we can see window, FPS game here. This is my resolution because on my screen is 1080p, so this is kind of like part of it. Anyway, it works. So what I'm going to do next is just move this to some class that I'm going to call engine. And here it can be public. We don't need these usings. So I'm just going to copy this. And here I'm just going to create initialize. That's fine. It already auto-resolved usings for me as well, which is super nice. And here for window, what I just want to have are basically events. So here I'm just going to pass on load, and I'm going to have window update. I'm going to say on update, and I'm going to create this now. So this one is on update, double delta time, takes delta time, void on load, has no parameters here or arguments, and then similarly we're just going to have on render. All right, that's basically it. So what did I do? Basically, load is going to run once when our window is basically loading. So we're just going to use it to place assets here and stuff like that that we need to load one time, basically images, textures, sounds, stuff like that. On update is going to run, and similarly on render every frame. On update is going to contain game logic, on render is going to contain rendering code. And we're going to do that next time because I didn't want to spend like too much time coding, explaining stuff. So next time we're actually going to try to set up WebGPU and maybe look at some of its features. And for this time, actually we're done. I just wanted to recap real quickly what WebGPU is. So actually we can skip recap for now. We're going to, I wanted to showcase something actually, and here I have a small project and it's running with WebGPU, but when using WebGPU you can kind of specify which backend do you want, and here I specified Vulkan. So I'm just going to run that project through a NVIDIA debugger so that we can see how it actually looks like. And remember, this is the WebGPU running. So here is the project. It's nothing special, it's not important what it is. What I wanted to showcase is this. If I capture the frame, all of these here are Vulkan calls, and we can confirm that if I try to capture this, and here it says API is Vulkan. But if I was to change it, and here I'm just going to terminate this, I'll go back to project and change this to direct 3D12. I just need to build it and run it again. So we're just going to run it again. Here is the screen, blah blah blah. We can move around, it's not important. I captured frame once again, and if I try to export it now, let's try this. it says direct 3D 12. So that's kind of important with WebGPU. You actually don't run direct on graphics card like you would with Vulkan or any other API. You actually run the Vulkan DirectX 12, OpenGL, Metal, whatever your platform supports, directly with WebGPU. And it's kind of like a wrapper, but not really, because it's a standard on its own. So if somebody once decides, okay, let's make a GPU functions on graphics card and run it directly, they can do that. It's a standard. But for now, actually, we run it through Metal, Vulkan, DirectX 12. That's what I wanted to mention. That's important to know, because if you want to debug it, you're actually going to debug those as well, right? The WebGPU itself has kind of validation layer. It's going to throw errors, but if you capture a frame stack, like I did now with Inside Debugger, and we're going to cover that in future, we're actually going to get calls for Vulkan or DirectX 12 Metal or whatever. So that's important to know. So if you enjoyed this video, please like, subscribe, maybe leave a comment. And next time we're going to start obviously with WebGPU, and we're just going to try to set it up and clear the screen just to have something, because we need to have a start, and we're going to discuss these things a bit more in detail. So that's it for this video. Please leave a comment, subscribe, maybe like video, and until next time.